All right, so we are doing 2-8 today, and we're doing it in two parts. So the first one is starting with absolute value equations, and then the second half is going to be absolute value inequalities. So just to throw it out there, if I ask you for the absolute value of 3, what is it? Absolute value of 3 is 3. All right, what's the absolute value of -3? It's also 3. So what's the definition of the absolute value? How far a number is away from 0. That's a definition of an absolute value. So 3 is 3 units to the right of 0, and -3 is 3 units to the left of 0. So they're both 3 units away from 0. The positive and negative is the direction. So the absolute value, there's always two things that will give us that value of 3, a positive 3 or a -3. Now, reverse it. Consider the absolute value of x is 7. What does it say in words? Well, a lot of you would say, well, it says the absolute value of x is 7. What it's really saying is the distance away from 0 is 7. So what are the options for x? The distance away from 0, the distance away from 0 is 7. That's what we're saying. The distance away from 0 is 7. What could x be? All right, well, what's 7 units away from 0? -7 or +7. So x could be 7 or x could be -7. I guess I'll put a question mark on here and put my quotes at the end. And I know I probably shouldn't end the word be, but we're okay. All right, so same idea. I have the absolute value of x equals -4. What does this say in words? You're telling me it doesn't exist? Okay, well, what's it saying in words? In words, it's saying the distance away from 0 is what? Yeah, the distance away from 0 is -4. And you told me that's impossible. Do we agree with him? Yeah. Okay. Distance away from 0, this is impossible. Distance can't be 0, direction. So at this point, we would say no solution. And we could write out no solution, or we could use the no solution set. Okay? All right. Now, we are solving absolute value equations. The first thing you're going to need to do is to isolate the absolute value expression. So you're actually going to solve for the absolute value. And then you're going to create two cases, the positive case and the what? Negative case. So we're talking about, I'm going to say what's inside could be positive or what's inside could be negative. So we're always going to have two answers, and then we're going to solve both equations. But this is big. You are going to check for extraneous solutions. Extraneous solutions can also be called false solutions or erroneous solutions. It's going to look like it works and it looks like an answer, but if we plug it back in, we have to throw it out. So sometimes you, just like a false positive, when you're testing for something in science, you run through it and it looks like a great answer and you go back and you realize it doesn't work. Absolute value should always be equal to a positive. So the absolute value of something would be +7. Will the absolute value ever give me a negative outcome? No. Now, what if I manipulate and I put a negative sign out front? That's different. But the final absolute value should always give you a positive outcome. So if I see something like this, I would say, hey, there's no solutions. This will never be true. Okay. Let me define extraneous solutions for you a little bit. It is a solution that, a big word, guys, emerges. It's actually not a big word, but it emerges while solving an equation. But it's not going to be a valid solution. So it's going to come out when you're doing the math. So it's a solution that emerges while, I wrote while twice, while solving an equation, but it's invalid. And you will catch that when you check your answers. So really important to check. When you do your check, you want to always go into the original problem. Okay, do you see it says right here, original equation. Okay, so every time I solve an absolute value equation, I'm going to break it up into two cases. The first step on doing this is to isolate the absolute value. Do you see that my absolute value is isolated? Okay, what I want to make sure we understand is treat your absolute value like a little armored car. Nothing goes in, nothing comes out of them, right? I can't distribute anything to it. I can't subtract the 7. What's in here is going to stay. So I could say the absolute value of 3 is 3. Do we agree with that? But the absolute value of -3 is also 3. That's a big idea in here. What's inside 2k plus 7 could equal 3, but what's inside 2k plus 7 could also equal what? -3. So this is the method that we're teaching it here. What's inside is not changing, but the absolute value of 3 would be 3, and if I made this -3, it would also give me the absolute value of 3. So then I'm going to solve these two equations separately. So subtract 7, 2k is -4, divide by 2, and what does k equal? -2. So that's one answer. Same method over here. 2k equals -10, divide by 2, and I get that k equals -5. You could use the word or and here. I'm not going to be picky here. Then we get into inequalities. The word and or is very important, just like our compound ones. All right, now before I say my answers are done, I want to check it. So in order to check it, absolute value of 2 times -2 plus 7, we want to know if it equals 3. Okay, well, this comes down to being -4 plus 7. The absolute value of 3 is 3, so it checks. Are we good there? Then I'm going to plug in my other answer. Absolute value of 2 times -5 plus 7. Make sure your absolute values don't turn into 1s. Should equal 3. Well, that's -10 plus 7. And I get the absolute value of -3, which is 3. So I'm happy with that. So both answers are good. Box them, circle them, do something with them. Okay? Now, look at number 2. First thing in the steps was to isolate the absolute value. So is the absolute value by itself in number 2? No. All right, so what are you going to do? Multiply by what? -2. So it's divided by -2. We're going to multiply. We're not doing that to distribute. We're doing it to cancel. Multiply both sides by -2. So I have y minus 10 equals 12. Okay, now, if I had the absolute value and it was equal to -12, I could tell you there's no solution. We're done, right? Absolute value can't equal negative. When we isolated it, the negative sign canceled out. So you have to isolate before you determine anything. And then we're going to say, hey, what's inside could be 12, or what's inside could be what? Okay, do you understand what I'm doing to break this down? It's the big concept that we need to use today and we need to use tomorrow. Are we good with that? So what I'm really saying when I do these two pieces is the absolute value of 12 is 12, and the absolute value of -12 is 12. You're truly doing substitution. The absolute value of 12, I'm replacing this and saying it could equal 12 or -12. Okay, add 10. So I get y equals 22. Add 10. And I get y equals -2. All right, before we say we're done, let's do a quick check. Now, when you check, you want to go back to the original. So 22 minus 10 all over -2. You guys do have that absolute value key in your calculator. If you go to math, I think the first and then over, one of those first options is ABS. I think it's over to like number. So go to math and arrow over to number. I don't know that you need that. I think you should be able to deal with this. This is the absolute value of 12 over -2, which is 12 over -2. And yes, we get out that original -6. Check it going the other way. Absolute value of -2 minus 10. Well, that's the absolute value of -12 over -2, which is 12 over -2. And yes, we get out that same answer. So both check. I'm happy with my answers. Okay, so we've seen two basic problems. Both had answers that worked. We always should have two cases. All right, good to flip it over? Okay, on the back here. What do I do with this number 3? What? Both of you saying divide by? Okay. So remember I said the absolute value is like a little armored car. They're not parentheses, so you can't distribute. We want to get rid of that 16. So I agree with you guys, divide by 16. And I've got the absolute value of r minus 5 equals negative 2. All right, get yourself set and decide what you're doing next. I mean, I'm done. Why are you done? Do you guys agree? Once we isolated it, the absolute value cannot be equal to negative. Now I have to isolate it first. If this was a negative 16, it would have divided out and we would be fine. But it wasn't, so no solution. Now, I don't want to do all the work, but if you did the work, if you were just not paying attention, you said r minus 5 equals negative 2 or r minus 5 equals 2. If you do the work and you plug the answers you get back in, it's going to tell you you're wrong, okay? So that's one thing, because the absolute value will never equal negative. Okay, what's different in number 4? I mean, the absolute value is isolated, but there's more stuff, right? Like before, it was just the absolute value, and then you just had a number. Okay, well, remember how we said a positive version or a negative version? So the absolute value is isolated. That 3x minus 9 equals exactly the x plus 1, or 3x minus 9 equals the opposite of x plus 1. Do you notice I put the parentheses there? Because when I say the opposite, it's not just negative x. It should be what? Negative x minus 1. So we're not ever changing what's inside the absolute value. That we're stuck with. But the answer, the positive version of the answer is leave the signs alone. The negative version is distribute it. Okay? I want to throw one more thing out there. If this was x minus 1, the positive version would stay x minus 1. So when I say the positive version, it doesn't mean make everything positive. It's meaning give it back as it was. And then the negative version would be to change all the signs. Okay, now I have to solve it. I'm going to move the variable first. So I get 2x minus 9 equals 1. I could add 9 at the same time or do 2 steps. I get 2x equals 10. And so x is 5. All right, go ahead and finish up this next one. So add x. I'm at the same time going to add the 9, but if that bothers you, can do 2 steps. And divide, I got x equals 2. All right, how do we check it? Go back to the very original. 3 times 5 minus 9 should equal 5 plus 1. Okay, well, that's 15 minus 9, which is 6. And the absolute value of 6 is 6, so I'm happy. Next one, 3 times 2 minus 9 equals 2 plus 1. I have to keep looking at what I'm doing. All right, well, that's 6 minus 9, which is the absolute value of negative 3. And the absolute value of negative 3 is 3, so I'm happy with that too. Both answers work, so I am going to box them in or circle them. But you want to check your answers. All right. What about number 5? What? Decimals? Well, I'll tell you what. If there are decimals, I'd prefer you guys leave them as fractions. That's also the same thing in Delta Math. Delta Math does not want you to put, cannot decide which way to go. Delta Math does not want you to put decimals in, especially if you're rounding them. So always keep the fraction version. Before I do anything, I'm going to isolate the absolute value. And so I have the absolute value of, or h plus 8 equals 7h. Now, I have h on both sides, but that's okay. We're going to have those two versions. H plus 8 equals 7h, or h plus 8 equals what? Negative 7h. Okay. I'm choosing to move the h to the right just so I can move it once. I have 8 equals 6h. Divide by 6, and this is what I'm talking about. I'm going to leave a fraction of 4/3. I don't want that repeating decimal. Let's keep that reduced fraction, but reduce it. Okay, subtract h. I get 8 equals negative 8h, and divide by negative 8. What does h equal? Negative 1. Okay, I'll give you a minute to go ahead and check your answers. Let's talk about it. All right, when I go to try the 4/3, you want to use a calculator, that's fine. You want to check it in the originals. And so I would put in 4/3 plus 8, and then see if that equals 14 times 4/3. It's not real pretty. I would probably show this by hand, but I'm just going to throw it in the calculator. 4/3 plus 8 ends up being 28/3. So it's going to be 2 times 28/3, and 2 times 28/3, it's the absolute value. All right, so I end up with 56/3. And then if you take 14 times 4 and keep the 3, you should get the same thing. Yep, 56/3. So I just used the calculator because it was quicker than me showing all the math there. So that one works. I'm happy with it. But when I go to plug in the negative, let me go back to, here's my original. Well, I'm way up there. Plug it into the original. 2 times negative 1 plus 8. Oh, no. That should be absolute value. Equals 14 times negative 1. Okay. Well, this is going to be 2 times the absolute value of positive 7, which is 14. And over here, I get a negative 14. And that doesn't work. So that's considered an extraneous answer. So if you get an extraneous answer, you need to be very clear about it. You should not erase the work. That is your proof that you did it. I'm just trying to clean this up because I think it's hard to read. So leave that work, leave that answer up there, but make sure you're clearly throwing out what answer doesn't work and showing which one you're counting. Okay? So that is considered an extraneous or a false answer. Okay. Number 6, what do I need to do first? Oh, if both would happen to cancel out, which isn't common, then there'd be no solution. The only time that both would cancel out is if it was originally equal to negative and you sort of missed that. So if it was like number 3, then both answers would cancel out because it was never going to work. Okay. All right. Number 6, what do I need to do to start? Okay. I need to add the 5n, so I need to isolate the absolute value. So always isolate the absolute value. 8 minus 2n equals 6n plus 2. Okay, now we have 2 cases. So do me a quick favor and set up those 2 cases. Isolate first, then 2 cases. Okay, when you're doing your notes, here is my first case where I left everything as was, or what's inside the absolute value equals a negative version. You can distribute the sign when you start. However, I just don't want you to forget it, so I think it's really important to show. Go ahead, do whichever way you want to solve it. I am subtracting the 6n, and at the same time, I'm moving the 8 over. If you want to do multiple steps, that's fine. I got negative 8n equals negative 6. And yep, we get a fraction again. It should be a positive 3/4. All right, when we go to do the next one, I'm going to distribute that negative sign, and then I'll start moving things. And again, it's up to you how you want to do it. I'm getting a positive 4n equals a negative 10. We should end up with the same final outcome, n equals negative 5 halves. I'll give you a second to make sure you catch up. What do I need to do with those answers? Check them. So guys, normally when we say to check it, a lot of kids don't. They're like, well, I'll just check the answer with the key, or I'll check with the neighbor. On a test, obviously you want to check. These are problems that you have to check because of the extraneous solution. Okay? So when you go to check it, go back to the very original. It's a little tedious. You probably want to use your calculator with the fractions, but you could do it by hand. I'm going to have to do my check in 2 rows here. All right, so there's that. Now, this calculator is not exactly yours, but I'm just going to use it. So just in case you're wanting to figure out how to do it quickly in a calculator, I am going to go into my math key, arrow over to number, select my absolute value, type in 8 minus 2. This one doesn't have a great fraction key, so I have to go for it here. So if you're putting in the fraction, which I just screwed up, there's my 2. My fraction is 3 over 4. This is probably why I just do all my math by hand, because it's just easier for me. And then I will do another fraction of 3/4. Okay, so on the left, I get 3 halves equals, and 3 over 4, and this would be the same as 8 over 4, and I get, no, I should not. I should be getting the same thing. I'm trying to see if I screwed something up, guys. Oh, I know what I got wrong. Hold on. Do you see what I did wrong? I wrote it as a mixed number. Do you see my 2 3/4? Yeah. This needs to be times. I got 11. Yeah, it should work. I didn't put my little time symbol in there. All right, so I agree with your 11/4. Do you see my mistake? This is why I don't use calculators, and I just use my brain. Okay, and then this would be 8 over 4, so it should be 11/4, so this answer works. All right, do you see why I use my brain instead of my calculator? There we go again. 8 minus, and what am I doing? 2 times negative 5 halves. Minus 5 times negative 5 halves, and that should equal negative 5 halves plus 2. Boy, this is a lot. All right, here I go again, trying to put it in my calculator. So absolute value, and then 8 minus 2, parentheses, I got it this time, don't you worry. Again, my calculator is different than yours. I didn't grab the one that you have. I wonder if it likes the negative. I don't know if it's going to let me do the negative. All right, and then minus 5, and then, watch it tell me error. We'll see. Negative 5 over 2. Okay, it lets me do it. So this one gave me 51 over 2. Does anyone agree with me? And then this would be 4 over 2 if I convert that, and that gives me negative 1/4, and that is just not going to work, so I'm throwing out that answer. What say?
Yeah, the bottom equation.